Now, we introduced the concept of stoichiometry originally with this pancake recipe. And we also looked at the possibility of having 8 eggs and more than enough flour and more than enough baking powder. But what happens if we have 3 cups of flour, 10 eggs, and 4 teaspoons of baking powder? How do we know how many pancakes we can make if we don't have what's known as an excess or more than enough of the ingredients? We have a finite number here. How do we figure that out? Well, what we do is we look at the amounts of each individual ingredient, and based on the recipe, we figure out how many pancakes we can make. So let's look at flour. If we have 3 cups of flour, and 1 cup of flour makes 5 pancakes, then 3 cups will make 15 pancakes. If I have 10 eggs, and 2 eggs makes 5 pancakes, then I can make 25 pancakes from 10 eggs. And I have 4 teaspoons of baking powder, and half a teaspoon of baking powder makes 5 pancakes, then I can make 40 pancakes. Now, once we have the amounts that we can make, we can see how many pancakes we can actually make. So the amount of pancakes we can make is not the largest number here, but instead it's the smallest number, because after we make 15 pancakes, our flour runs out. And even though I have enough eggs and baking powder to make more, once we're out of flour, we cannot make any more pancakes. The same happens in chemical reactions. We have finite or limited amounts of each reactant, but whichever one runs out first determines how much product we're going to get. So, in chemistry terms, the reactant that runs out first is what's known as the limiting reactant. It limits how much product we can get. And in this case, our limiting reactant will be flour, because after we make 15 pancakes, it runs out, even though I have enough eggs and baking powder to make more. This 15 pancakes, the maximum I can make based on my ingredients, is what's known as my theoretical yield. So the limiting reactant is the ingredient or the reactant that runs out first, and the theoretical yield is the most that I could possibly make. Now notice this value is the smallest, because after the flour runs out, I can't make any more. So in chemical reactions, the chemical that runs out first is known as the limiting reactant, also known as the limiting reagent. And the maximum number of product we can make depends on this. It's known as the theoretical yield. And it will also determine the amounts of the other ingredients that we'll use. Limiting reagent problems, I'll refer to as LR problems, limiting reagent or limiting reactant, are just a type of stoichiometry, because as we saw in our pancake example, we used our ratio from our recipe to figure out how much each reactant will make, how much product each reactant will make. We're going to do the same thing with LR problems. As in all stoichiometry problems, all the reactants must be in moles. If necessary, if we're given mass, we'll have to get to moles by dividing by the molar mass. Once we're in moles, we do a mole ratio with a chosen product for each reactant. Some chemical reactions have more than one product, and if that's the case, we'll just have to choose one product and stick with it. The reactant that makes the least product is what's known as the limiting reagent or the limiting reactant. And the theoretical yield is the amount of product formed from the limiting reagent. After the limiting reagent runs out, no more product can form. So let's look at this example. What is the limiting reagent and theoretical yield when 0.552 moles of aluminum react with 0.887 moles of chlorine? And here's our balanced equation. Well, the first thing we want to do is write down what we're given. We're given amounts in moles of both of our reactants. And since we're in moles already, we don't have to convert to moles. Then what we're going to do is we're going to see how much product each of these reactants can make. And since we only have one product, we don't have to choose a certain product to use. So here are our conversion factors. 2 moles of aluminum chloride are equivalent to 2 moles of aluminum. That came from our balanced chemical equation. And 2 moles of aluminum chloride equivalent to 3 moles of chlorine. That came from our balanced equation. So here's our balanced chemical equation. Here's what we're given. 0.552 moles of aluminum, this reactant, and 0.877 moles of chlorine, this reactant. We're going to have to do a mole ratio with each reactant and the product. And here's the relationship between them. 2 moles of aluminum equivalent to 2 moles of aluminum chloride, 3 moles of chlorine equivalent to 2 moles of aluminum chloride. Let me put that equivalent there. So we have to do a mole ratio with each reactant. I have moles of aluminum here. I need moles of aluminum down here. And when I do my math, my moles of aluminum cancel out, and I get 0.522 moles of aluminum chloride. If all my aluminum reacts, this is how much aluminum chloride I get. Now let's do the same for chlorine. This is how much chlorine I have, and according to my balanced equation, 3 moles of chlorine are required to form 2 moles of aluminum chloride. My moles of chlorine cancel out, and when I do the math, I get 0.56267, and I should have 3 sig figs, so 0.563 moles of aluminum chloride. They're pretty close, but this one is the smaller one. This right here is my theoretical yield. This is the most aluminum chloride I can make, and my LR, let me just put in a box here, is aluminum. It is the product that runs out first. After I make this much aluminum chloride, I have no more aluminum. It makes the least amount of product. This is the most product I can make, and this is my LR. Now let's look, does our answer make sense? It is often hard to judge because there are multiple factors, but if we go back and check our math, we see that aluminum does give us the smaller amount of aluminum chloride, so our answer does make sense, and based on our given values, this is a reasonable answer.